So I'm going to start off with another 8th grade standard. Our objective will be to simplify exponential expressions so that we'll take something that's a little longer or larger, an expression that's a little longer or larger, and make it smaller by simplifying it using the rules for properties of exponents. But I'm going to go over some basics about rules for exponents, and then we'll actually get into the actual exponent property rules. And that will, the exponent property rules, they'll probably come, and it's going to probably be on this fourth page. I'll probably make videos for those maybe on Friday. We'll start at those actual rules. But let's talk about the basics. All right, so some of the basics about exponents. So exponents is just repeated multiplication. That's all it is. So if I have something like 4 squared, everybody knows that's an exponent of 2. That just means you're going to multiply the 4 twice. 4 times 4 gives us 16. So again, exponents represent repeated multiplication. Or if you have something like 5 cubed or 5 to the third power, that's just 5 times 5 times 5, which is 125. And let me give you one more. If I have something like 2, this is read as 2 to the 5th power. That means you're going to multiply that 2 out 5 times. 1, 2, 3, 4, 5. And guys, I will tell you it will equal 32. Because these 3, 2 times 2 times 2 is 8. 2 times 2 is 4. And 8 times 4 is 32. So 2 to the 5th power is 32. So again, exponents represent repeated multiplication. The number that is being multiplied is called your base. So when you all had those squares and cubes, see like this number 4, that's called a base. That's the number we're multiplying. Or 5 is called my base because it's the actual number we're multiplying. Here 2 is called my base because it's the actual number we're multiplying. So the number you're multiplying that is being multiplied is called your base. Now, the number of times the base is being multiplied is called the exponent. I think everybody knows that. You may hear exponent of power, but I just basically say exponent. The whole thing is called a power, guys. So that square, 4 is your base, 2 is your exponent. But we call the entire thing power. So sometimes you'll hear me say 4 squared, or you'll hear me say 4 to the third power, or 5 cubed. Excuse me, guys. 5 is your base again. 3 is your exponent. The exponent is going to tell you how many times to multiply that 5. But this whole thing is called a power. So sometimes you'll hear me say instead of 5 cubed, you'll hear me say 5 to the third power. All right. Let me erase some of this, because I'll leave it and keep going. All right, let's look at this example. It says the product, and I didn't have little time signs at the time I made this on Word, guys. So I used a little asterisk. So the product of 3 times 3 times 3 times 3 times 3 times 3 can be written as 3 to the 6th power, guys. Because you have 1, 2, 3, 4, 5, 6 threes you're multiplying together. So it's 3 to the 6th power, where 3 is acting as your base, and 6 is acting as your exponent. Now, I'm going to talk about something quickly. In order to evaluate an exponential expression, you're going to write the product in what we call expanded form and then simplify. So if I wanted to evaluate 5 to the third power, 5 cubed, you write it in what we call expanded form. So this is called exponential form, guys. You'll hear me use that word or that term a lot. Exponential form. The reason why it's called exponential form is because it's written with the exponent. See? Exponent and exponential. But this is called expanded form. When you expand something, you're making it larger or bigger. Not really bigger in terms of value, but you're just writing it out, okay? So expanded form is when you get rid of the exponent and you just write out the numbers however many times the exponent tells you to. And this is a simplified version. 5 cubed, or 5 to the third power, is the same as 5 times 5 times 5 in expanded form. But the answer simplified is 125. Or I can say when I evaluated 5 cubed, I got an answer of 125. So if you ever hear me say evaluate, give me the simplified answer, okay? Basically, they're the same thing. Evaluate means to simplify. Give me an answer. All right, so what we're going to practice, guys, is we're going to practice writing these things out in words and then writing it out in expanded form. As a product will be expanded form. And I'm not asking you to simplify it. So I'm not asking you to evaluate and give me an answer. Oh, yes, I am. Let's put that. It's not in my, it says write each in words and as a product and then evaluate. Okay, I didn't put that in my problem in each of these. I got words and as a product, but I forgot to put evaluate. So that's my fault. We'll evaluate these two. We need to because these two are going to be very different. It's important that we do evaluate or get an answer for those. All right. But a lot of times when I say read this, some students can't read that. They don't know how to read it properly. I get 4/5, like it's a fraction. That's not how you read that. So we're going to talk about how to read this, and this is what we call, it's written in exponential form because it's written with the exponent. But how do I read it in words? So when we get ready to talk about this in class out loud, I want you to know how to read these powers. So you're going to read the base. The base is 4. So you're going to have 4. And you're going to say 2 the what power? Well, what's the exponent? The exponent is 5. So you're going to say 4 to the 5th power in terms of words. And then as a product, and also what we call expanded form, writing it out, you're going to write out 4 to the 5th power. 4 to the 5th power simply equals 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. That's what you call expanded form or writing it out as a product. Sorry, guys. Product means you just write it out as a multiplication problem, okay? Now I'm going to evaluate. You need to write this in on your notes. So simplify, give me an answer. So I know 4 times 4 times 4 is 64. And I know 4 squared is 16, or 4 times 4 is 16. Basically, I have 64 times 16. And we'll just multiply that out. I don't feel like multiplying it out by hand. 64 times 16, and that's 832. So that's how I evaluate or simplify, guys. All right, let's take a look at the second one. Number 2. Number 2, again, is in exponential form, but I'm going to write it out in words. There are 2 different ways to write this out in words. So I can write the base, which is 9, and just put the exponent. So I can write this as 9 cubed. Okay. Or you can write this as 9 and put to the, and then what's the exponent? It's a 3, so we say 9 to the third power. Either way is fine. Okay, now as a product or in, again, what we call expanded form when we write it out, that's just 9 times 9 times 9. And you all, that's a perfect cube. You should be familiar with what the answer is. If you simplify, evaluate that, that's 729. All right. Number 3, 7. This is going to be read as the base 7. And you're going to put to the, and then you're going to go with fourth power. The base is 7. Here the base was 4. Here the base was 9. I always put your base first. And then write it out as a product or, again, what we call expanded form. So that's going to be 7 times 7 times 7 times 7. And when I evaluate that, I'm just going to look at this. I know 7 times 7 times 7, based off of perfect cubes, is 343 times 7. I could have said 49 times 49, but I just know 7 cubed is 343 times 7. That's 2,401. All right, let's take a look at number 4. You can pause the video and do number 4 on your own. Don't forget to do the evaluate part on number 4. All right, this is what you should have. Your base is 10. You're going to put 2 the, again, it's fifth power, 10 to the fifth power. That's how you read it. How do I write it in expanded form as a product? 10 times 10 times 10 times 10 times 10. That exponent of 5 tells me to multiply that 10 5 times. And then I'm going to evaluate. I'm going to look at this as 10 to the third power, 10 cubed, which is 1,000. And then 10 squared is 100. That's 1, 2, 3, 4, 5 zeros. So 100,000. Okay, 5 and 6 are a tad bit different because 5 and 6 have negatives attached to them, okay? But only one of these bases is -5. The other one is just 5. So I'm going to go back to base again. Again, your base is just the number you're multiplying. So the base here is 4. The base here was 9. The base here was 7. The base here was 10. All right, let's talk about these bases when you have a negative that's in parentheses and one that's outside. If your number is negative, it will be in parentheses, guys, okay? Or if it's written in expanded form, it may not be in parentheses. Like if you're given something in expanded form and you see this, I know my base is actually -3. So it's just -3 to the fourth power. I know that because each one of these numbers is -3. But you may see things that look like this as well. In this particular case, my base is a 3, not a -3. I know about somebody saying, well, that number looks like a -3 and the rest of these are like positive 3s. No, you're going to read this differently. Your base, you can't write two different bases to the same power, okay, or to one power. So 3, 3, 3, positive 3, that has to be a positive 3. We'll figure out what to do with that or how to read it. Proper number 5. But your base here is not a negative 3 because all your 3's aren't negative. Okay. But let's take a look at number 5. I would not write this out as 2 negative 5. So somebody's going to think you write it out as negative 5 times negative 5. But your base isn't negative 5. If it were negative 5, it'd be in parentheses. Okay? The negative would be in the parentheses. So how do you read this thing then when you got this negative, but it's not in parentheses like it is on number 6? So you read this as the opposite. That negative sign, instead of reading it as negative 5 to the second power, you read it as the opposite of, and then your base is 5. So your actual base is 5, not negative 5. The opposite of 5, and I could put 5 squared because it's an exponent of 2. Or I can put the opposite of a base of 5 to the second power. Okay, so you can write it out as either of those two ways, but do not read this as a negative. It's not in parentheses, okay? So my base is 5. I just read that as the opposite of 5 squared, or the opposite of 5 to the second power. So writing it out in expanded form. If I write this out in expanded form, it's the opposite of 5 squared. That's it. You just keep the opposite sign or that negative sign in the front, but you write these 5s as 5 times 5. But this just stands for the opposite of 5 times 5. Well, what is 5 times 5? 5 times 5 is 25, and the opposite of 25 is negative 25. So when I evaluate this thing, I get the opposite of 25, or negative 25. Now watch number 6, because it's a tad bit different. Number 6, I can say my base is negative 5 because it's in parentheses. So I can say the base is negative 5. So since I can say the base is negative 5, I can write a base of negative 5. So I'm going to put negative 5. That's my actual base. I know that because the negative is also in the parentheses with the 5. So the whole negative 5 is being squared. Negative 5 squared. Or you could write negative 5, your base again, negative 5, not 5, to the second power. Now writing it out in expanded form, you write your base. Well, your base is actually negative 5. So I write negative 5 times negative 5. And you all know negative times a negative, or anything squared is positive. So if I'm squaring the negative 5, that means I'm writing the negative 5 twice. That negative times a negative will produce a positive. Now it's very different from number 5. Number 5, if your negative sign is not in parentheses, it's not going anywhere, guys. It'll always stay. So even if you had something like this, your base could not be considered as negative 7. Your base is 7. You don't even read this as negative 7 cubed. You read it as the opposite of 7 cubed. And everybody knows 7 cubed is 343, but the opposite of that would be negative 343. Now, if I have something like this then I consider my whole base as -7. Okay, -7 times -7 times -7, which in this case is actually still -343. You just have to work it out to see whether your answer is actually negative or if your answer is positive in this case. In this case, it was 2 negatives I multiplied, so I ended up with a positive. In this case, it was 3 negatives that I multiplied, so my answer remained as a negative. But in cases like this, where like this right here, where your negative is not even in parentheses, your answer is always going to be negative because it's read as the opposite of some positive base raised to some exponent, okay? Hope that makes sense. If it doesn't, pause the video and let me know. All right, let's take a look at the bottom where it has practice. So it says, write each expression using exponents, but we will not evaluate in this particular case. We just want to write it using exponents. In other words, we want to put it in exponential form. So kind of the opposite of what we just got finished doing on 1 through 6. On 1 through 6, we use expanded form. But here I was given expanded form. And now asked to put it in exponential form. But on 1 through 6, I was given exponential form and asked to write it in expanded form. So just working backwards. Okay, so we just need to put our base first. So our base here is 2, and our exponent will be the number of times we're multiplying it. 1, 2, 3, 4, 5, 6, 7. 2 to the 7th power. Number 2, I actually have 2 bases. Got one base times another base. One base is a 6, and it has an exponent of 2 times another base. The other base is a 5, and it will have an exponent of only a 4, because I have 4 of those. That's all you do. 6 to the 2nd power, or 6 squared times 5 to the 4th power. All right, number 3, I also have 2 bases. One base times another one. One of those bases is a 9, and its exponent will be 9 to the 4th power, times the other base, which is a 4, and it will be 4 to the 3rd power, because I have 3 of those. Now, I'm going to say this. I don't like the fact that when I type these notes up, I put these in parentheses. Really didn't mean to do that. I'm going to rewrite this as -3 times -3, 5 of these. Okay. I'm going to rewrite it like this. Here I know my base is actually -3. How do I know my base is -3? Because each one is -3. So each number is -3. So I have to put my -3 in parentheses to show that the entire base is the base also includes the negative. So which means your base is -3, not just the opposite of 3. So use the parentheses, and your exponent is 5. 1, 2, 3, 4, 5. Now I'm going to make up an example. You're going to write this on your paper. I'm going to use the dot instead of the X. Okay, guys, when it comes to writing the base, please do not say your base is -3. It's not. Because if your base was a -3, every one of those numbers would say -3. But I definitely don't see a -3. Definitely don't see a -3. Don't see a -3. Don't see a -3. This looks like a -3, but it's not, guys. It's just you have a base of 3, and you read this as it's 3 to the 1, 2, 3, 4, 5, 5th power. But you're going to read this as the opposite of 3 to the 5th power. So you just stick that in front of it. So your answer, if you were to evaluate it, would be negative anyway, because 3 to the 5th power would be positive, and the opposite of some positive would be negative. But again, you can tell if your base is actually negative or positive. Because right here, all these are negative 3s. So you know your base is negative. So if you know your base is negative, don't forget to use parentheses before you raise it to an exponent, please, okay? All right, let's talk about the power of 0 rule. And a negative power rule. So when I say power of 0, maybe when you have something like this, 3, 2 with an exponent of 0, or negative power 3 with an exponent of negative 2. Okay, so that's what I'm talking about. But what we're going to do is see if we can look at a pattern to establish what our answer should look like if we have an exponent of 0 or some type of negative exponent, okay? So let's take a look. We're going to start with 2 to the 5th power and just try to use patterns to help us develop what something to the 0 power equals and what we do when our exponent is negative. All right, 2 to the 5th power, we're going to write it out in expanded form. That's 8 times 4, which is 32. And 2 to the 4th power, that's 8 times 2, which is 16. Okay, so I want you to take a look at something. 2 to the 5th power was 32. 2 to the 4th power, when my exponent decreased by 1, my answer changed to 16. Now, if I do 2 to the 3rd power, what is my answer going to change? In other words, notice that my exponent keeps decreasing by 1, but I still have the same base 2. But 2 to the 3rd power, we know is 8. 2 to the 2nd power, 2 squared is 4. So the pattern on my exponents is I'm keeping the same base, but my exponents are decreasing by 1. So I should go to 2 to the 1st power. 2 to the 1st power. And even if you didn't know 2 to the 1st power was 2, you should be able to tell if you're decreasing 5, 4, 3, 2, 1 by 1 in each exponent, you should be able to see what you're doing to get from 32 to 16, 16 to 8, 8 to 4, and 4 to 2. Well, I'm dividing by my base. My base is 2. I'm dividing my answer by my base to get to the next smallest exponential power, okay? So my base was 2. 32 divided by 2 is 16. What is 16 divided by 2? 8. What is 8 divided by 2? 4. What is 4 divided by 2? 2. All right, now let's keep decreasing in exponents. 5, 4, 3, 2, 1. What is the next decreasing exponent? A dang on 0. There we go. 2 to the 0. What's that going to equal? Well, if you continue the pattern of dividing by your base of 2, what is 2 divided by 2? What 2 divided by 2 is 1. So it says if the pattern continues, what would 2 to the 0 power be? Should be 1 if the pattern continues. Okay, now I want to take a look at some more patterns just with a different base and see if I work my way down from a higher exponent to an exponent of 0, will I still get a 1 with a different base? So take out a sheet of notebook paper and let's just try looking at some more with a different base, okay? Okay, let's try a base of 4. And let's try 4 to the, I don't know, we'll try 4 to the 5th power too. Okay, 4 to the 5th power was on this page. It was 832. It's number 1. And if the pattern would continue, I should be able to divide by 4 and get the next answer. Okay, 4 to the 4th power, that's 16 times 16. 16 times 16 is 256. But take your calculators and divide 832. I'll show you right here. We don't have to get a calculator out. 832 divided by 4 and see if I get 256. 2. I didn't mean to do that. Let me check something, guys. And it's 832. Hold on one second. 4 to the 5th power is 64 times 16. Oh, okay. I know what happened. So we got to go back and fix something on the notes. So glad I did that. Everybody go back to number 1. 64 times 16 is not 832. It's 1024. My fault. Okay. So go back and fix it. It's 1024. So go back and fix number 1. So now 4 to the 5th power is 1000. What did we say? 24. And 4 to the 4th power is 16 times 16, which is 256. But let's divide 1024 by 4, that base. And let's see what happens. All right. 4 will go into 10 twice. 10 minus 8 is 2. 4 will go into 22 5 times. And 4 will go into 24 6 times. Okay. All right, now let's work on 4 to the 3rd power. We all know 4 cubed is 64. But if you divide 256 by 4, you will also get 64. And you can check it. Remember, you should be doing this on note paper. All right, and we know that 4 squared, 5, 4, 3, 2, 4 squared is 16. And 64 divided by 16, by 4 is 16. 4 to the 1st power is 4. It's just 1 4. 16 divided by 4 gives me that 4. So 4 to the 0 power. What's 4 divided by 4? Okay, so it looks like it doesn't matter what my base is. If my exponent is 0, it looks like the answer is 1 if my exponent is 0. Okay, let's try one more just to verify our proof or what we're thinking, okay? Let's try 3. Let's just start up with 3 to the 4th power. 3 to the 4th power is 3 times 3 times 3 times 3. I'm going to say 9 times 9, which is 81. And 3 cubed is 27. Let's keep decreasing in terms of our power exponent. 3 squared is 9. Am I dividing by that base of 3? Yep. 81 divided by 3 is 27. 27 divided by 3 gives me that 9. 9 divided by 3 should be 3 to the 1st power, which is 3. And 3 divided by 3 should give me 3 to the 0 power, which is 1. So I hope everyone is able to see and write this little note that any base to a power of 0 would equal what? Just by what we looked at. Okay? All right, now, let's go back to the original problem with a base of 2. We go back to the original problem with a base of 2 and continue our pattern. So let's go right here because we figured out, we kind of reiterated and solidified what an exponent of 0 will give you, just give you 1. Let's talk about what a negative power would give you, because everybody knows we start an exponent of 5, and we go to 4, and then 3, and then 2, and then 1, and then 0. The next decrease would be 2 to the negative 1. 5, 4, 3, 2, 1, 0, negative 1, negative 2, and so forth, okay? All right, so if I continue the pattern, I'm going to divide 1 by 2. 1 divided by 2. And somebody's going to say, oh, that's 0.5. It is 0.5. But I don't want to write it as a decimal. If you split 1 in half, you do get 0.5. I don't want to write it as a decimal. I want to write it as a fraction. So I'm going to keep writing these as fractions as 1 half. So it says if the pattern continues, what is 2 to the negative first power? Put the fraction form for me. 1 half, okay? It's not wrong if you put the decimal form. 2 to the negative first power is 0.5 or 5/10. But I'm going to write the fraction form because I need you to see what you're going to do with your base, okay? The base, or the number, or the term raised to the negative power. Okay? Let's take a look at the second one. I'm going to divide. It says if this pattern continues, what will be 2 to the negative second power? So if I divide this by 2, just keep dividing by 2. I'm going to put this over 1. But because I wrote it as a fraction, I'm going to keep, change, and flip. So it's actually going to end up being 1 half times 1 half. Or you get 1 over 4. 1/4. When you divide by 2. You know, when you divide a fraction by a number or another fraction, you use keep, change, flip. Okay. I'm going to write this another way. It can also be written as 1 over 2 squared. Okay. And let me go back and color code these. I need to do something. So we all know that the pattern was dividing by 2. Let me color code that so we can see your original answer. Or 2 over 1, and we just see it keep, change, flip. And that's what it equals, okay? Now, if we continue with the pattern, what will 2 to the negative third be? Well, the original 2 to the negative second was 1/4. So if I take 1/4 and divide it by 2, or 2 over 1, I can keep, change, flip. I'll end up with 1/4 times 1 half, which tells me that it should give me 1/8. Now I'm going to write this as 1 over 2 cubed because 8 is the same as 2 cubed. Okay, so watch what I'm doing. I'm going to use the word or. All right, if the pattern continues, what would 2 to the negative fourth power be? So I am going to take 1/8 and divide it by my base. My base is 2 again. But because it's fractions, I need to keep, change, flip. Now I'm just dealing with fractions. So that's going to give me 1/8, change, division, multiplication, flip that. So it's 1/8 times 1 half, which tells me that this answer should be 1 over 16. Or I can put this as 1 over 2 to the fourth power. All right, if the pattern continues, what would 2 to the negative fifth power be? So I'm going to take 1 over 16 and divide it by 2, my base. I'm going to keep, change, flip. So it equals 1 over 16 times 1 half, which ends up being 1 over 32, or 1 over 2 to the fifth power. All right, so you're going to take out a sheet of notebook paper for me because we're going to kind of put some things together, okay? And we're only going to focus on the negative exponents. All right, so take out a sheet of notebook paper. Pause the video, take out a sheet of notebook paper. And you're going to write what I write. All right, heads up. I hope we're ready. So here we go. I'm trying to go to a space that has plenty of room. Okay. But this goes on your notebook paper, okay, guys? So I'm going to put this back at the top. Okay. I want that at the top. All right, now this is what I want to make a chart. We had 2 to the negative first power. It was 1 over 2, okay? 2 to the negative second power was 1 over 4. 2 to the negative third power was 1 over 8. Make sure you're leaving some room. 2 to the negative, and that doesn't look like a 3, that looks like an 8. 2 to the negative fourth power was 1 over 16. 2 to the negative fifth power was 1 over 32. Okay. This is what we call numerical form. But I also gave you the answer in, I said you can write it another way. It was with an exponential form. Exponentially, this is 1 over 2 to the first. Exponentially, this is 1 over 2 to the second. Exponentially, this is 1 over 2 to the third, because 8 is 2 to the third. Exponentially on this one, this is numerical. And then exponentially. Okay, just write out exponential. I'm running out. Okay, I got enough room. This was 1 over 2 to the fourth. And this was 1 over 2 to the 32 was 2 to the fifth. 1 over 2 to the fifth. All right. So I want to focus on the exponential form. Okay? I want everybody to focus on from here to here. Or from here to here. From here to here. From here to here. And from here to here, guys. Okay? I'll go back and focus on the numerical in just a minute. All right, but I want you to notice something. If it has a negative exponent, my base, if it was raised to a negative exponent, my base was flipped to the bottom and not the top. So a base of 2 is the same as a base of 2 over 1. Why? Because a base of 2 is the same as 2 over 1. They're the same number. All right, so this base was flipped when it had a negative exponent, because this is still really a base of 2 over 1. But when the exponent is negative and I want an answer, I can just flip it to get it. So I can flip that base of 2, put it on the bottom. Instead of the numerator, it goes to my denominator. But when it does that, the exponent is no longer negative. The exponent is positive. And everybody knows that 2 to the second power is 4. Or look at here. A base of 2 is actually a base of 2 over 1. But my base of 2 moves from the numerator to the denominator when the exponent is negative and the exponent becomes positive. So, and everybody knows that 2 to the third power is 8. So what I'm trying to show you guys is when you have a negative exponent, a base raised to a negative exponent, that base moves from one, either from the numerator to the denominator, and the exponent changes and becomes a positive. Now, sometimes you can have a base with a negative exponent in your denominator. But guess what? If I flipped it, it would move from my denominator to my numerator, and the exponent will become positive. Anytime you flip it, because the exponent is negative, it just moves from the numerator to denominator, or denominator to numerator, and your exponent changes. This base of 2 is just 2 over 1, but my exponent is negative 4. So if I don't want to write it with a negative exponent, I just flip my base from numerator to denominator and change negative 4 to positive 4. And we know that 2 to the 4th power is 16, so I end up with 1 over 16. Here, a base of 2 is the same as a base of 2 over 1. It has a negative exponent. I can flip it. My base of 2 would move from numerator to denominator. But if I move my base of 2 from one part of the fraction to the other, the exponent also changes signs. And we should all know that 2 to the 5th power is 1 over 32. Okay? So if I gave you 2 to the negative 6th power, your base of 2 is actually a 2 over 1. So I can move this 2 to a denominator, because right now 2 is in my numerator. So if I move the 2 between numerator to denominator, if I move the base, I got to change the exponent, sign of the exponent. So I move the base, and then you can't have a blank in the top, so you got to put a 1. Okay? You can't have nothing left in the top. You put a 1. I can have an understood 1 in my denominator, but I can never. Like here, the reason I can just say 2 to the negative 6 is because there's an understood 1 that I don't actually have to write. Okay? But if you write something like this, you can't say, oh, there's an understood 1. No, you better put that 1, because we need it, okay? All right, and 2 to the 6th power, I know that ends up being 2 times 2 times 2 times 2 times 2 times 2. So that's 1 over, that's 2 cubed, 8. That's another 2 cubed, 8. That's 8 times 8, which is 64. So 2 to the 6th power would be 1 over 64. So that's one way you could get your answer. So let's go back to the notes. And I'm going to look up here, where I had 3 to the negative 2nd power. 3 to the negative 2nd power can be rewritten. A base of 3 is the same as a base of 3 over 1. The 3 can be moved from numerator to a denominator. But if I move my 3 from my numerator to my denominator, I must also change the sign of my exponent, but I put a 1. So this is 1 over 3 squared, or 1/9. So 3 to the negative 2nd power is 1/9. Okay. All right, now I want you to go back to one more thing. I'm going to show you something, guys. Look at these numbers up here. 2 to the 5th power was 32. But yet 2 to the negative 5th power was 1 over 32. Okay? Because these signs are opposites, one's positive and one's negative, then the answers are what we call reciprocals of one another. Reciprocal is just when you flip something. Okay, you flip it. If I flip 32, which is 32 over 1, it becomes 1 over 32. Okay, let's take a look at 2 to the 4th power. 2 to the 4th power, and I wish I had more room. I'm going to have to erase some of this stuff. Gosh, dang it. Hold on. Yeah, I got to erase some of it because I don't have enough room. 2 to the 4th power was 16, but 2 to the negative 4th power was 1 over 16. So when you have the same base, but the exponents are opposites, the answers will be reciprocals of one another, 16 and 116. So 2 to the 3rd power is 8. So 2 to the negative 3rd power is the reciprocal of 8, which is 1 over 8. 2 to the 2nd power is 4. So 2 to the negative 2nd power is the reciprocal of 4, which is 1 over 4. 2 to the 1st power is 2. So 2 to the negative 1st power is the reciprocal of 2, which is 1 over 2. So if you know what the positive version is, you can just write the negative version. If you know what the answer is when it has a positive exponent, you should know what the answer is when it has the opposite exponent, okay? So I am going to erase this, and I want you to continue to write these on your notebook paper. Let me erase this. So it's going to be 2 strategies I'm going to really focus on with you with negative exponents, okay? And the strategy you use is up to you. One strategy will be to think about its positive counterpart with a positive exponent and just use the reciprocal. So if I gave you 5 to the 3rd power, well, we know 5 cubed is 125. So 5 to the negative 3rd power will be the reciprocal of 125. That just means flip it. So it would be 1 over 125. Okay, that's option 1, to think about the positive exponent version. And then when you use the negative exponent version, let's think about the positive exponent version. The other thing is, if you have the negative exponent, now I probably should have started off with that first. If you have the negative exponent and you want an answer to it, just remember, use the reciprocal 2 and move your numerator to denominator. But when you move from numerator to denominator or denominator to numerator, change the sign of your exponent. So we end up with 1 over 5 cubed, which is 1 over 125. So if I gave you 4 to the negative 3rd power, you could say, okay, well, 4 to the 3rd power is 64. So 4 to the negative 3rd power must be 1 over 64. Or you could go this route. You could say, it has a negative exponent. Let me use the reciprocal of base 4. So instead of the numerator having a base 4, my denominator will have a base 4. But if I move it from numerator to denominator, the sign of the exponent changes. You got to have a 1. You can't have a blank in the top. So 1 over 4 cubed is 1 over 64. Either way, if you have 6 to the negative 2nd power, you could think about what 6 to the 2nd power is. Well, 6 squared is 36. So 6 to the negative 2nd power would be the reciprocal of that, or 1 over 36. Or you could say, let's take this base of 6, which is really 6 over 1, and flip it. So instead of having the numerator containing the 6, the denominator would contain the 6. So I move from numerator to denominator. I'm going to N for numerator, D for denominator. But if I move my base from one place to the other, the exponent will always change signs from picture 1. So that's 1 over 36, guys. Now, some of you are saying, what, will it always move from numerator to denominator? Well, sometimes if you have something like this, suppose you have this. In this particular case, it would move from, now it's in your denominator and it's negative. So now it would move to your numerator and the sign would change in picture 1. But when the one's on the bottom, you don't really need it, guys. Okay, but you can put it, you don't need it. 5 squared is 25. 25 over 1 or 25. So 1 over 5 to the negative second power is just 25, okay? If you had something like this, I don't know, we had 1 over 7 to the negative third power. Well, my denominator has the negative exponent. So I could just move my 7, my base, to the numerator and change my sign. You can put the understood 1 if you want to. So we would just end up with 343 over 1 or 343. So basically what I'm telling you is if you have a negative exponent, just flip the base. All you're doing is flipping the base. You can flip the base, or you can think about the positive version and use the reciprocal. Okay? So let's go back to these notes. This is what I want you to put down here. If your exponent is negative, use the reciprocal and change the sign of the exponent. And then you can simplify if you want to. Okay? Reciprocal just means flip it. So if it's in the numerator, flip it to the denominator. If it's in the denominator, flip it to the numerator. But only if your exponent is, key thing, only if your exponent is negative. If your exponent is negative, don't worry about it. Don't worry about trying to use the reciprocal, flipping anything. Okay? Okay, so let's just kind of reiterate this. Let me see how long this video is. I don't know how long I've been. I'm scared to touch it because it might jump off. Ooh, too long. Okay? All right, so let's take a look at this. The zero power rule. A stands for any number. Any number to the zero power, guys, is 1. I don't want to put any number, so I just use A. A could be any number. So 707, the base, this base to the zero power is 1. Be careful on something like number 2, because your entire base isn't 2m. Here your base is only m, and it's just multiplied by 2. I know that because 2m is not in parentheses. That's just like when I go back to something like this. Here my entire base was -5. So all of -5 should have been squared. Here my base was only 5 because it wasn't in parentheses. Okay, so here your base is only m because the entire 2m is not in parentheses. So I'm only going to change m to 1. And something key for you all to remember, guys, exponents only apply to what is directly to the left of it. So you have the exponent 0, and directly to the left of 0 is just m. 2 places to the left of 0 is the number 2. So I'm just worried about what's 1 place to the left of the exponent. Okay, when I say directly, I mean sitting right next to the exponent. And don't worry about the 2. The 2 is 2 places. This 2 is 2 places from the exponent 0. So that 0 only applies to the m. Now, If the 2 and the m were in parentheses, the 0 would apply to the entire base of 2m. Okay, it would apply to the whole thing. In this particular case, if it were in parentheses, the whole thing would change to 1. But here, only the m is going to change to 1. So when I know when something is mashed together, I don't want to write 21. I want to write 2 times 1. So this simply equals 2. Now, in this particular case, this whole entire thing it's in parentheses. So this whole entire thing, no matter what it is, if it's in parentheses and it's raised to the 0 power, the entire thing will change to 1. I don't care how weird it looked on the inside. It could have something like this. If all this stuff is in parentheses and it's raised to the 0 power, it's 1, 2. Y'all add this to your paper. Here, the 0 only applies to the variable x. It's because it's x to the 0 power. So only the x is going to change to a 1. So basically, it's 5 times 1 y squared, which is just 5y squared. 5 times 1 is 5. You all know when it's mashed together, it means multiply all the stuff. So I can multiply the two numbers. All right, let's take a look at this. Negative power rule. A or any number or any, it doesn't have to be a number, any number or variable or term or expression raised to the negative exponent. So I'm going to say base A is the same as base A over 1. So instead of having A in my numerator, I'm just going to put whatever that variable is or what number or whatever it could be in my denominator. But I need to change the sign of my exponent. So in symbols, negative m will change to positive m, and don't forget to put your 1. And in words, it's just what we wrote right here. It's the same thing. I'm not going to write it again. If your exponent is negative, use the reciprocal and change the sign of the exponent. Reciprocal, numerator, denominator, denominator to numerator, flip it, basically. All right, let's take a look at some. All right, here your base is 7. So I'm going to flip the 7. It's like 7 over 1. 7 is the same as 7 over 1. So if I flip it, 7 will move to my denominator. And change the sign. So I end up with 1 over 7 squared in exponential form, or 1 over 49 in numerical form. Here, this negative 4 only applies to the b. So basically, this whole thing is over 1, but only the b is going to flip to my denominator. Because right now it's in the numerator. So I'm going to flip it to my denominator, and negative 4 is going to change to positive 4. The 3 stays put because, it's just a regular number. The only thing I need to flip are those things that have been raised to a negative exponent. Everything else you just leave alone. Anything not raised to a negative exponent, when I say raised to, which means it doesn't have or has a negative exponent. When I say raised to a negative exponent, it means it has a negative exponent on it. But anything not raised to a negative exponent stays put. Basically, don't move it. So I'm not going to move the 3. 3 is not raised to the negative fourth power. B is. So it stays put, okay? All right, this whole thing is raised to the negative third power. I know that because it's in parentheses. So I'm going to move this whole thing from numerator to denominator. And if the whole thing was raised to the negative third power, the whole thing will be raised to the third power when I put it in, when I move it to my denominator. So keep it in parentheses. Just leave it like that. I got rid of the negative. Guys, a simplified expression you can't leave a negative, okay? In a simplified expression, you can't leave a negative exponent. So if you're going to simplify an expression or your directions tell you to, get rid of any negative exponent that you see. So let's take a look at number 4. Okay, so the C is raised to the negative fifth power and the B is raised to the negative third power. So keep in mind, anything not raised to a negative exponent stays put. B, well, let's look at C. C is in my numerator. So I'm going to flip it to my denominator. Change the sign of the exponent. B is in my denominator. So I'm going to flip it to my numerator and change the sign of the exponent. But what about this stuff that's not raised to a negative exponent? Well, leave it in your numerator. Just leave it up there. That's all you do, because it doesn't have a negative exponent on either one of them. All right, guys, I am not going to go over, I'm going to go over the power of 1 rule, but this negative base rule I'm going to save for tomorrow when I do this, okay? Or I may just do this tomorrow, the negative base rule tomorrow, and do this another day, okay? Yeah, I'll probably do it that way. But let's take care of this power of 1. Anything raised to a power of 1 is just whatever the base is, like 545 to the first power is 545. This whole thing is raised to a power of 1, so the answer is just negative 3n. Okay. 5 raised to the first power is just 5. Negative 5 raised to the first power, or the opposite 5 raised to the first power is just opposite of 5 or negative 5. Even if you see this, it's still just negative. It's just whatever the base is, okay? This is the opposite of 5 to the first power, which is negative 5. And this is negative 5 raised to the first power, which is just still negative 5. Okay, but this, I'll do a short video on it tomorrow. And I'll let you work on some classwork, okay? All right, thank you, guys.